So, the Fick equation. The Fick equation is going to combine two different things. It's measuring the physiology of flow and consumption. And you can pick different things in your body to measure, but we almost exclusively are going to measure oxygen consumption. So, in our case, oxygen consumption. So, what is flow? Flow we measure at the heart. Oxygen is delivered to our body through blood, okay? And therefore, flow is the blood coming out of the heart. We can simplify this as the heart rate times the stroke volume So if you multiply the number of beats per minute by the amount of blood being ejected from the heart, you can determine flow, which again is summarized as Q, cardiac output. Okay. So, in summary, Q is equal to heart rate times stroke volume. Now the other part is consumption of oxygen. So consumption happens in your muscles, and that's what we're trying to measure. So what you take a look at is the red line here, which is your arterial blood, okay, which is oxygen rich. So it brings the oxygen to the muscle. And if you could measure that and measure how much blood and how much oxygen there is in the blood, and then you measure on the other side the blood leaving the muscle, and you say, okay, in venous blood, which we call mixed venous, just because it's mixed up when we measure it with other venous blood, the difference between the two. So the difference here between oxygen in and oxygen out tells you the consumption of oxygen of that muscle. The goal with the physiology we're doing is to measure that across the whole body. The problem with this is it's difficult to do. So let's just summarize what that looks like in the equation. A minus VO2 difference. So the Fick equation is the big one to write down. VO2 would be equal to the heart rate times the stroke volume times the A minus VO2 difference. The Fick equation. Very important. If you want to summarize heart rate and stroke volume, it can be rewritten as VO2 Q times A minus VO2 difference. And we'll see how to solve that with the Stringer equation in a minute.